Hey guys, this is Mitch with FindPoint CGI, and today we're going to talk about the 2D navigation system inside of Godot. So we're going to go through the process of building out a small environment. Then we are going to add a navigation polygon instance. We're going to go through any of the options that navigation polygon instance has. Then we are going to actually trace out and do our navigation. Next, we will be setting up a small character that follows your mouse around using the navigation system. Finally, we are going to go ahead and use collision avoidance so that our objects will avoid colliding with dynamic objects. So that's what I have in store for you guys today. Let's go ahead and get started. Okay, so we're going to create a 2D scene. So I'm going to click on 2D scene. And with navigation inside of Godot 3.5, a lot has changed. I know I covered a little bit of navigation back when it was in, I believe, alpha or possibly beta, but some things have changed. So that's why I'm making this update video. Now, first, we have to talk about how to actually create navigation. So if I just kind of drag in a little icon like this and I make it about, I don't know, about this big, let's say, and I duplicate it and I just kind of drag it like this and I duplicate it and I rotate it. And I'm just going to create a small little scene that we can navigate through. That way we have something to play with. But basically, let's just say we did something like this, okay? And let's say we want to have a character here navigate to wherever my mouse is, okay? Obviously, we don't have a character yet, but first, let's actually create our navigation stuff. If we right-click on our node 2D and we add in a child node and we type in nav, you'll see that we have navigation 2D, navigation polygon instance, navigation agent, and navigation obstacle. And of course, we have the 2D versions of those. Now with Godot 3.5, navigation 2D is not dead, but it is dying. We are no longer going to be using the navigation 2D element. Instead, we have this navigation polygon instance that we can use. So if we add in the navigation polygon instance, you'll see that we have a little triangle here. And this triangle means that we need to have a resource for this navigation system to work. So if we come over here to the right, you can see we have a nav poly. If we select that and create a new nav poly, that'll hook up our navigation poly instance so that way we can have 2D navigation. Now, if we click on this, you'll see that we don't have any special information here or anything like that. So you don't have to worry about, doing any additional configuration. Now, let's run through the options here and then we'll talk about how to build a navigation poly. First, we have enabled, whether or not it's enabled. Navigation layers is the layers at which a navigation client and a navigation layer will be able to interact. So basically, think of it kind of like your movement layers. So if something's on 1 and something's on 2, they won't mix, they won't interact. Enter cost is how much it costs to enter in to the navigation polygon, and travel cost is how much it costs to travel through it. Okay, so a lot of times if you wanted to create a weighted system for navigation, you could say, okay, this to enter into this navigation, it's going to be a 2. And then if you had another navigation poly next to it that was an enter cost of 0, then the navigation system will go towards the 0 versus the 2 because it's going to be less cost overall. Now, that's basically the large majority of the options with navigation polygon instance. So how can we make a navigation polygon? Well, if you come up here, you can see we have 3 options up here. The first one adds vertices, the second one selects vertices, and the third one deletes vertices, okay? So right now, if we click on the add polygon here and we click, you will see that we added in a vertex. Now, if we drag this down and we click again, we will have another vertex. Drag this guy down here, just like that. Drag this guy up here. And then we can basically just trace out what we want our navigation polygon to look like. Now, one thing that you have to keep in mind is hard edges are actually difficult for the navigation system to handle. So that's something to keep in mind. Now, you will notice that by doing this method, it automatically created our navigation polygons. And that basically is super nice, right? You can basically say, hey, just create them. And you'll also notice that the polygons have all of these stretched edges and things like that. And a lot of times when you're creating your polygons, you're going to want to make it so it's not quite as stretched out. So you could just kind of come in here and click, and you'll see that it kind of adds in polygon instances, and you can kind of fiddle with it until you get, something that feels good, that makes sense. A lot of times when I'm doing this, I just kind of click and try to build a decent polygon structure here that actually allow players or objects to get caught on our navigation polygon. So now that we have our navigation polygon instance, we have to add in something to work with our navigation, right? And in this case, I'm just going to add in a little small character that we can just have follow our mouse. I think that'll be the easiest way to show how this works. So if we right click our node 2D, we add in a child node, and we add in a kinematic body 2D, and we right click our kinematic body 2D. We drag our little icon in just like that, and that'll kind of throw a little sprite in there for us. We need to add collision to it, so let's add in a child node, and let's add in a collision shape 2D. Now, something that I have noticed is square shapes tend to get caught on stuff, so you might want to avoid a square if you can. I've noticed that it tends to cause problems with the navigation system every once in a while, so I will throw a circle shape on, and we will make it about this big, so that way we have some form of collision on our object. And last but not least, we have to add in the thing that tells us that it's a navigation object. So if we right click on it, add in a child node and add in a nav, and then you see here we have navigation agent. And navigation agent basically says, hey, this is a thing that exists in navigation, which is really useful. So if we double click on that and add that. Now, if we head over to our inspector, you'll see that we have a bunch of options here. So if we click down pathfinding, you'll see that we have a boatload of options here that we can work with. First is path desired distance. This is the desired distance for your path. And basically think of it kind of like this. In your path, you have these dots. And it's saying, hey, from here, go to this dot, and then go to the next dot, and then go to the next dot. This number basically says how far away you can be from that dot before it says, yep, you've made it, move to the next one. So sometimes you might want to increase this if you want to smooth out your character's movement or something like that, or you might want to decrease it if for some reason they're getting stuck on geometry. That would be a good thing to take a look at. Target desired distance, this next one, is basically how far away from the target point. So if your mouse is the target, how far away from your mouse can it be before it considers itself reached? And remember, that's from the center of your navigation agent, not from the overall size of the object. So you have to keep your object size in mind when you're doing this because it really matters. Path max distance is how far can your target be before it stops trying to track it with the navigation engine. And the reason why is because if you have something like 400 meters and you have all sorts of obstacles and stuff like that, the amount of time it's going to take to resolve that distance and that path is going to be extremely large. So we need to make sure that our max distance is not so high that it's going to cause problems. So they expose this so that way we can adjust it, so we can kind of tune our game for ourselves. And navigation layers, as I said before, if you're on navigation layer 1 and your path's navigation polygon instance is on layer 2, then they're not going to talk to each other. So that's just something to keep in mind. And of course, if you want something to run with a different polygon or a different navigation system, you can by using navigation layers. Now, under avoidance is our next big section, and this is where things get interesting. So you have avoidance in the new version of Godot, and avoidance allows it to avoid non-baked navigation objects. So you could basically say, hey, avoid objects and don't collide into them. But by doing that, you are increasing the amount of calculations it has to do. So therefore, you're going to slow your game down by a fair amount. And generally speaking, I haven't seen too big of a performance drop from it, but from what I've talked to other people, they've said that it depends on your machine, it depends on, how good your processor is and stuff like that. So that's just something to keep in mind, that avoidance can be pretty processor intensive from what I understand. Now, avoidance enable just enables it. Radius is how far away an object can be before it starts detecting it and attempting to avoid it. Neighbor distance is how far away it's going to look to find its neighbors. So for instance, it'll say there's a neighbor this far away. It's 300, units away. My radius is 10, so I don't need to worry about avoiding it. But if it detected somebody that was 9 units away, then it would say I have to avoid that, so I'm going to take actions to avoid it. Max neighbors is basically how many neighbors it's going to track per character or per navigation agent for avoidance. Time horizon is how long it's going to take for your navigation agent to detect and avoid your object. Now, I know you might be tempted just to drag that down to basically 0, do it immediately, but just remember that doing that is going to really impact your performance. So this is an important slider here because it's accuracy versus performance here. So that's kind of what the slider is all about. Max speed is how fast your object will move when it's using avoidance. So something that's interesting, and I'll go through this when I show you guys the coding side, because Godot uses a signal to determine the velocity of your object, it takes this max speed into an account with how fast it can move. So this is important when you're doing your code, because this will determine how fast that object is allowed to move on the nav mesh. So that's just something to keep in mind. So now that we have all of that out of the way, and I know that I just dumped like a whole brick worth of information onto you, let's actually jump into coding this and actually, have this thing following our mouse. So that way you guys at least see how this all works. So first, I'm going to drag this little guy, providing that I can. Let me click on this, and then drag this little guy here. So that way we've got him moving around. And I think that'll be enough space. It might not be. So I'm going to drag navigation polygon. I'm going to give him a bit more space just because I don't know how it's going to react to not having very much space. With my collision size, it's definitely not necessarily ideal for this. So I'm going to drag this out, make it a little bit bigger just in case. And then I'm just going to grab my 2 icons and I'm just going to drag it down, something like this. That way we have some space here, because I just want to make sure that it's, stable and that it's not going to run into the wall for some reason because I don't have enough space. Now, if I right click my kinematic body, I attach a script, and we'll just call it nav tutorial.gd, and I probably should have named it nav2d tutorial, but that's okay. First, we need to get a reference to our navigation agent. So I'm just going to say var nav agent, navigation agent 2D, and I'm just going to say under my ready, nav agent is equal to $ navigation agent 2D, and that'll just kind of set that up. And yes, I know that you could just go equals $ navigation agent 2D as well, and that will technically work. I just like to have my stuff inside of my ready function because it's just a little bit nicer for me, but it's up to you guys on which one you'd like to have it in. Now, our agent has a signal called velocity computed. Now, normally this is not fired off unless you're using avoidance, but since I'm going to be demoing out avoidance anyway, we might as well just hook it up. So I'm going to say navagent.connect, and I'm going to connect. If we scroll down, you'll see that there's a velocity computed. So we'll just grab that, comma, self, comma, and I will add in an underscore on underscore velocity underscore computed, just like that. And that way we just have that hooked up. And I'll just make a quick function right here, and I'll put it actually below my process. So that way we have that. There we go. And the velocity computed, one of the things that I still wish Godot had was the ability for us to know what comes out of a signal, because unfortunately, you don't really know without just knowing, unfortunately. But what comes out of it is a velocity. So we'll type in velocity, so VELOCITY, and that will be a vector 3. You can type this if you'd like. Generally, I don't type. I probably should, but I really just don't. So now that I have this hooked up, let's talk about how we can actually use this to make our object move. So we're going to want to run this off of physics process, not regular process. And the reason why is because physics process is more stable. Regular process runs off of your frame rate instead of running off of your physics process, which is more of like your CPU, basically. So it's a more consistent frame rate. So you're going to want to do that with anything navigating related because it's just more consistent and easier on the navigation code. So now we'll just type function underscore physics process delta, and then we are going to actually start doing our navigation code. First, we have to check if our navigation agent is finished with its navigation. And if it is, then we can return. Okay, because we don't really need to process the rest of our navigation code if it's already finished. There's no reason to actually, navigate anything. Now, to actually do navigation, we need to get our target and we need to get our direction. We're going to need to get our velocity that we want. So basically how much velocity that we actually want. And then we are going to actually have to move our object. So first we'll say var target position is equal to nav agent dot get next location. And basically that's saying, hey, we're going to get our next point that we want to move to. Then we got to get our direction. And we're going to make that equal to our own position. So we can say global position dot direction to, and then we'll just pass in our target position. Okay. And that'll get our direction. Okay. And then we can get our actual, what we're looking for our velocity. So we'll say velocity is equal to direction multiplied by whatever speed we want it to be. In our case, it should probably be something like our agent's max speed, because our expectation is that our character can't go faster than our max speed anyway, so we should probably just make it the max speed. So we'll say nav agent dot max speed, just like that. And then we'll just pass in our velocity. So we will actually move and slide to our velocity. So we'll type in velocity, just like that. And there we go. And that's pretty much what we're going to need to do a basic navigation system. Now, how can we set our actual location that we are moving to? Well, in our case, we're going to use our mouse as our location, but we don't necessarily want to do it like every frame. We don't want to say, hey, here's the new location every frame, because that's a lot of extra processing that the nav agent's going to need to do. So what we'll do is instead we'll right click our kinematic 2D object. We will add in a child node, and let's add in a timer node, and then we will connect our timer node timeout, and we'll just say on timer timeout. That's fine. We'll connect that to right here, and what we'll do is we'll say nav agent dot set target location, and we'll set that to get global mouse position, and that'll just set its location to our mouse position. Now we're going to need to do this on timer timeout. So if we click on our timer and we go to our inspector, you'll see our wait time is about 1 second, which is not ideal but not bad. But we can drag this down to probably about a half a second, maybe a quarter of a second. And what we can do is we can say auto start is on. And the reason why we want auto start on is so that it runs on startup on the application boot. So that way it starts navigating immediately. So now if we hit play, you'll see that it is following our mouse. Just like that. Now you are seeing some issues where it's not updating the navigation fast enough, and that's why we're getting some of that stopping. And that's because it thinks that we are at that spot and we're not. So if we kind of drag this down maybe to maybe 0.13, see if that's better. Yeah, that's a lot better. But you can see now it's actually navigating as you would expect, which is awesome, right? So we got our basic navigation working. But that's how we can do a very basic navigation, okay? And of course, we can adjust our wait time to be nice and small, and there you go, right? We'll have a nice little navigation system that doesn't have dynamic object avoidance. So how can we do dynamic object avoidance? Well, to do that, we need to turn it on. So first we have to go to our navigation agent and we have to turn on avoidance enabled. And inside of here, instead of moving and sliding our velocity right here, we can just basically take that and move it into here. And then here, we have to tell our agent to set our velocity. So we can say nav agent dot set velocity, and we can pass in our velocity just like that. And what that's going to do is it's going to have it compute our velocity and set up our velocity and do all the work that it needs to do an animation, to do our movement code, but it's going to do it in a safe way. So if we actually run this and we move our mouse, you'll see that really not much has changed, and it's still having some struggling with the being caught on some things. And I think that that's because of our polygon instance is being difficult. So we might want to add some more points to help it out. But in general, you'll see that that all worked like normal, right? But where it changes is now we have dynamic object avoidance. So let's create a quick little obstacle that we can use in our project. So if we come up here, we right click our node 2D, we add in a child node, let's add in a kinematic body 2D. We'll call this obstacle, and then we will right click it, add in a child node, add in a collision shape right here. We're going to make that into a small cube, just like that. And if we take a look at it, you'll see that we have a small little object right here. And I'll just drag in the Godot icon just like that. And I'm going to change its size to kind of match the collision shape just like that. And I'm going to right click my little kinematic body and I'm going to add in an animation player just like that. And I will move our obstacle. And I know I'm going pretty quick, but you guys can definitely do all of this. It's just normal Godot stuff. I'm going to move it right about here. And I am going to tell it to move up and down with an animation. So I'll go into my animation player. I will add in a new animation and I'll just call it move. Simple enough. And I will grab our obstacle here. I'll click on our transform. I'll put a keyframe on our position here. And I'm going to set this to something like 3 seconds. At about 1.5, I want it to be right about here. We'll put a keyframe like that. And at about 3, I want it to have that. I want it to be back at its original point. So we have a little guy that goes back and forth just like that. Simple enough, right? So what can we do to make it so that Godot knows that this object exists and that it needs to be avoided? Well, that's where a navigation obstacle comes in. So if we right click and add a child node and type in nav, and you'll see that we have a nav obstacle 2D. So this is used for navigation and collision avoidance, right? So we'll double click that and you will see that we really only have one option, which is estimate radius. And that basically just takes the object we have here, and we want to make sure that we have it underneath our obstacle, by the way, or else it's not going to work. It takes this object and estimates its radius based off of the collision shapes that are under it. So if there's multiple ones, it'll attempt to estimate the radius for all of the collision shapes combined, basically. Now, if we've done everything somewhat correctly, this should, in theory, work. So we'll go ahead and hit play, and it's not actually playing the animation. Go to our, and that way we have an animation. And we'll make sure that we have loop on, and we will click on our animation player. And under our playback options, instead of doing an idle, let's do it in physics. And that way it matches up with our navigation system. So hopefully all this will be set up correctly. So now we can come over to our animation player, right click it, attach a script. I'll just call it animation player.gd. That's fine. And I will just type in play move, and I'll just let it play that move animation on startup. So now if we play this, there we go. So now if I move this guy, it should have some collision avoidance, which it's doing it for the most part. And you'll see that it is struggling a little bit on that little, it seems like something here is probably some kind of issue with the navigation polygon. But it is avoiding colliding with the object or running through the object. And that's basically what we wanted. So you can see it is working. So that's good news. We look at our navigation polygon. Let me see this real quick. I think there, that might be better. There, let's try that. Still struggling a tiny bit every once in a while, but it's better than what it was, and that's more of what we were trying to do. So anyway, that's basically how you do 2D navigation with collision avoidance and without collision avoidance inside of Godot 3.5. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I am here to make content for you guys. This video, as with all of my videos, was a viewer suggested video. So if you have any suggestions, please leave them in the comments below, and I'll be more than happy to put them on my Trello board, which I have a link to in the description below. And I will get to it as soon as I can. I do have a C# Steam tutorial that I've been looking into as of recently, so hopefully we'll be getting to that. And of course, I have a Blender tutorial that I am also working on. If you have any questions or comments, please throw them in the comments below, or jump on my Discord, links in the description, and I'll be more than happy to help you with any issues you might be having. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.